Okay, so factoring trinomial expressions is our last form of factoring. It's going to be probably the method you use the most. It's the most common method besides GCF. And it looks a little different than the past couple we've talked about, specifically because this is dealing with trinomials. So we have to go over what a trinomial is. So think back to binomials with something with two terms. So what do you think a trinomial is? So think about your prefix tri. Okay, so that tells me it's 3, right? Think about a tricycle and that kind of stuff, okay? So a trinomial is a polynomial that has exactly 3 terms. I spelled that word wrong. Whoops. Exactly. I was too excited. Exactly 3 terms in it. Okay, so that 3 is important. And the basis for a trinomial is going to be ax squared plus bx plus c. And I know that kind of looks like gibberish, but these a, b, and c values are real numbers. So a, b, and c, they are real numbers. And they're generally, for our purposes, are going to be integers. So they're going to be integers. They're not going to be fractions or decimals, really. So again, for what we're doing, you're pretty much going to see integers there for A, B, and C. Okay? So let's go over steps to factoring a trinomial. Okay, so maybe previously you've talked about things called sum puzzles or things like that, okay? So a sum puzzle is this x here in this example, and I'm going to explain that a little more. But our first step is to simply find factors to complete the puzzle. So find factors. Find factors to complete the puzzle. Complete the sum puzzle or the x. The x. Okay. Okay, so once you find those factors, the next step is to write them as binomials. So write factors or write factors, yep, as a binomials. Okay. So write these as binomials. And then the third step, which is one that most of you probably won't do, but is perhaps the most important, is to always check your factors. You want to make sure that you have your signs correct. Okay, that's going to be important. So let's look at example 1. So I'm just going to move this up a little bit. Let's look at example 1. So we want to find factors to complete the x here, the sum puzzle. So let's talk about this a little more. So we have an a value here, a b value here, and your c value, right? Remember that a, x squared, bx, and c. Okay, so keep in mind if there's no number written in front of the x squared, there's that implied 1 there. Okay, so in our sum puzzle, our b value goes in this top number, or this top part of the x. So I'm going to put an 8 here. Our c value goes down here, and I'm keeping the sign since they're both positive. My numbers in here are both positive. Okay, if it helps, write positive. So now we want to find numbers or factors of 15 that add up to 8. So let me say that again. We want to find factors of these that add to this. So that means I'm going to think of factors of 15. I have 1 and 15, 3 and 5. Okay. If I add or subtract 1 and 15, will I get 8? No. What about 5 and 3? If I add or subtract those, will that get me to 8? Hopefully you're thinking yes. And that's if we add 5 and we add 3. Okay, so we want to make sure all of our signs are cohesive. Okay, if we do a positive times a positive, that's going to give us a positive, so that works. If we add two positive numbers, that gives us a positive. So all of our signs are good. So we've completed our X. Okay, we completed this sum puzzle. So now we have to write these factors as binomials. So what that means is, since this first one was x squared, we always put an x here. And then whatever we get here for these side x parts, that's what goes in to complete the parentheses or to complete the binomials. Okay. So once you find those factors that multiply to 15 and add to 8, then you simply put them into the binomials. Again, it's really important to check your work. So I'm going to FOIL, and I'm going to get x squared plus 5x plus 3x plus 15, which does simplify to what we need of that x squared plus 8x plus 15. Okay, so I know that was a little confusing. So let's look at example 2 together then. So let's kind of walk through example 2. I'm going to highlight my A, B, and C values again. So I have my A value, my B value. So I'm highlighting the sign that goes with these values and my C value. So the first thing I do is plug these values into the X. So I know that my B goes on this top part of the X, and my B is a -10. And I know my C goes on the bottom, and it's a +24. So remember, you want to find factors of 24 that get me to -10. So first thing I'm going to do is list out factors of 24. I have 1, 24, 2, 12, 3, and 8, 6, and 4. Is there any combination of these that add up or subtract to get me -10? Well, I know 1 and 24 don't work, because that could either get me 25 or 23. 2 and 12 could work. Okay. Maybe it could work. So that's a possibility. So I'm going to keep that as a possibility. 8 and 3 could either give me 5 or 11. So those don't work. And 6 and 4 is a possibility. So now I have to narrow it down between 6 and 4 and 12 and 2. Okay. So we want factors that, when multiplied, give us a positive number. So that means both of my numbers either both have to be negative or they both have to be positive. But since I have a -10 up here, that tells me that both of these factors have to be negative. So if I have a -12 and a -2, does that give me a -10? No. What about a -6 and a -4? Does that give me a -10? Yes. So those are our factors then. The -6 and the -4. So now that we have these factors, that's what we plug into our binomials. Again, our x just stays x. And then we have minus 6, minus 4. Always check your work, okay? So I want you to pause, and I want you to try example 3. Okay? I want you to pause and try example 3 for me. Okay. So hopefully you tried a couple of different things. Maybe you had negative 10 up here and 14 here, and you realized that no factors of 14 could give us a negative 10. So think about if it's unfactorable, what could we write here? That it's going to be prime. Okay, so there's always going to be some prime numbers here. Okay. So I want you to try example 4. I just want you to fill out the x for me. So fill out the x, and then we can work from there. Okay, so pause and fill out. Okay, so hopefully you have all positives in here. So factors that added to a positive 10 from a positive 24 are 6 and 4. So normally we would fill in that this first number is a p, and then we would do plus 6 and plus 4. But what are we missing here? We're missing that x. And since it's with the 24, then it's with our factors here of 6 and 4. So it's not just p plus 6, it's p plus 6x. Okay, so that's really the only difference, is that we add that x into there, because now we have two variables. Okay, so now I want you to try example 5 and example 6. Example 6 is tricky, so I'm going to go over example 6 at the end, but I want you to try example 5. But I'm not going to go over 6, I'm just going to show my work. So go over, do 5 and 6 for me. Okay, so for number 6, you may have lots of questions, but keep in mind our first method for factoring is to take the GCF. So we haven't talked about if there's higher exponents, right? So you're like, we didn't talk about this, I'm not going to do it. So you just want to look for ways that you could solve it based off of what you know. So you know that you could take the GCF of things. So that's always something you have to look for, okay, GCF. Our GCF is negative 3p, because we want this p squared to be positive, just like all the other times. Okay, so then that gives us what's in here, okay? So now we haven't talked about, can these factors be different signs? Yes, they can be. If they need to be, they can be, okay? So that's allowed. It's not, not allowed. The other thing that I kind of glossed over is that doesn't matter what order these binomials are in. The answer is no, it doesn't matter what order they're in, okay? So you could have them flip-flopped, but always keep in mind that the GCF comes out front, and then you have your binomials. Okay, so now I want you to do example number 7. So example number 7, pause. Okay, so hopefully you get example C. For that, make sure you have your work. So some of you may be wondering, do I need to fill out this x? No. If you can do it in your head, go for it. But for those of you that need the x, please continue using it. Keep on writing it, okay? Do what you need to do with it, because it may not always be on your papers, okay? So let's go to the next page. Example number 8. This one's going to be kind of long, so bear with me. Okay, so I want you to read the beginning and letter A. So take a moment and read the first sentence and... Okay, so we want to find the area, and we're given the width and the height. Okay, so it says that the width is 4 inches longer than the height. So the height of my shape is here. This is the height of my shape. So I'm just going to label that as h for height. Okay. The width of my shape is this one, and it's the height. Well, it's 4 inches longer than the height. So I'm going to say my width is actually height plus 4 inches. Okay, so we're going to label it like that because it's 4 inches longer than my height. So now we want to find the area. So keep in mind when you're finding the area, it's length times width, or in this case, height times width. So our area equals height times width. So I'm going to plug this into the formula. So area equals height times height plus 4, since that's our width. And then I want a simplified version, okay? So I'm going to simplify this. So I'm going to distribute in that h. So now my area is h squared plus 4h. Okay? So make sure you have a label here. Don't forget our label is units squared. Okay. So now B. Kim's adding 3-inch wide frame to all sides of her canvas. So let's draw this out first. So I want to draw this out. So we had our original canvas here. Our original canvas. Now we're adding 3 inches to that on all sides. Okay, and that's going to be our frame. So remember, our original width was h plus 4, and our original height was h. But keep in mind, we're adding 3 on all sides of this. So what's our new height? Our new height is going to be h plus 6. Okay, h plus 6. That's because I'm adding 3 down here, and I'm adding 3 inches up there. So I'm adding truly 6 inches to that. Okay, so same thing with our width. So now we're adding 3 inches over here and 3 inches over here. So that's why it's height plus 6 plus 4. Because we're adding 6 more inches to the 4 that were already there, or simply h plus 10. So now we want to find the new area. So take a moment and find that new area. Okay, so hopefully you got h squared plus 16h plus 60 for your new height. Okay, so Kim doesn't like that. She's unhappy, so she's trying a different frame. And that new frame has an area of this. So it has a new area where h is the height of the canvas, which we knew. So now we want to find the new width. So I'm going to take this new area and I'm going to factor it because I kind of want to work backwards. Because we have our original values of h and h plus 4. Okay, so these are our OG values. We want to find our new values. So we want to find our new frame. So I'm going to do that by factoring. So I'm going to factor h squared plus 8h plus 12. So take a moment and factor that for me. Okay, so our new frame has our height going from h to to h plus 2, and our new width going from h plus 4 to h plus 6. So what's the difference here? How do we go from plus 0 to plus 2 and from plus 4 to plus 6? We added 2, right? So our width of our new frame is 2 inches. So you could be expected to solve something just like this on an open-ended. So you really need to make sure you understand why we did each part. So if you don't, please ask questions on that.